I think that's the seconds we were looking for.
There you go.
Okay,
Oh,
you're on.
ladies and gentlemen, coming off a very busy weekend for our club. Welcome again to the SBAU Astro Hour. I'm your proud host, Ronnie Herron, on behalf of Santa Barbara, California's longtime telescope and astrophysics club, the SB Astronomical Unit. I call it 93 million miles of fun with the sun. This is our 246th program for November 10th through the 16th, 2025. And our Astro Club meets first Fridays at the Santa Barbara Museum of Natural History. We meet after dark next to Palmer Observatory on the second Saturday of the month. All of that somehow was accomplished along with our SBAU planning meeting over the last 3 days. Come look us up, please, on our website, sbau.org, and see our webmaster Tom Totten's incredible postings of everything about the club. All right, these are the cosmic topics we're going to tackle this week. We're going to do our regular planetary roundup in the night sky, starting with Mercury and Mars, and then on to Venus, out to the gas giants, even some moons on the way. Speaking of Mars, Blue Origin Space Company's New Glenn, a new rocket, should have blasted off yesterday. We'll find out. Send 2 probes called Escapade, nicknamed Blue and Gold, out to orbit the red planet. Our interstellar visitor, 3i/Atlas, hasn't changed color. And no, Joe Rogan and Kim Kardashian, it's just a comet, not an alien visitor ship like they're insisting. We'll be focusing on the winter constellation Orion this weekend. Here's some interesting headlines from the New York Times. Get this, China is on a scientifically shaky mission to conquer aging. It includes longevity labs, immortality, islands, and grapeseed pills. Take your pick, gents. Doesn't have much to do with our topic, but pieces of a Chinese science satellite rained down on Florida. Did you guys see that?
No.
Incredible.
I saw a picture of the reentry debris.
It was not nighttime, it was daytime, wasn't it?
Right.
Looked
Looked
like one of those space shuttle disasters coming back. And we say goodbye to James Watson, who with Francis Crick helped discover the structure of DNA. He died at age 97, became one of the most important scientists of the 20th century. Gave us the old double helix, I guess. Okay, let's meet the very important people of the club, starting with our hopefully soon to be reelected next month, Jerry Wilson, beloved president, commander-in-chief here. Jerry.
Good morning. Good morning, Joyce. Good morning, Riley. And good morning, Calvin.
Calvin, Riley, Joyce, take the day off. Stay with us. And he's married to Pat Forgy, and she's in the club, and what a lady. Also married to a Pat, who is our merchandise manager, and our treasurer, Chuck McPartland, Santa Barbara Outreach Coordinator, and one of the best in the biz. He's out doing something almost every other day this month. I swear, I looked at the November outreach. There's 14 items, 15 if you count the switch over to standard time, but 14 makes it almost every other day we're doing something. Tim Crawford joined us, resident lens and telescope expert, longtime member. Wife is Karen. And doggone if Tom Whittemore didn't join us, editor of the monthly newsletter, past Westmont College former science instructor, now an incredible bread maker. I hope for the December holiday meal, Tom, if you come, you bring one of your loaves of freshly baked sourdough. I will just sniff the packages up there if I get a shot. And Bruce Murdoch, who is a supportive member and a very knowledgeable guy, married to Bonnie, and he's also president of the Santa Barbara Theater Organ Society. Now, if you're like me, you didn't get much silly stuff forwarded. That means we're going to hold our own here, seeing fresh cartoons as we do the silly science stuff, both thought provokers and some cartoons. There was one statement that was rather interesting. I hope you rerun that, Mr. President. Let's start the hour with some levity. Here it is. I was walking past a farm where a sign said, "Duck, eggs." I thought that's an unnecessary comment, and then it hit me. You're going to surprise us from now on, duck eggs.
No, I just forgot to do it. I was very busy weekend.
Well, that's a cheap excuse. We'll buy it this one time. Math used in real life. Do you want to explain this to us, Mr. President?
This is mathematics applied in real life situation. This guy or girl, whatever, is laying in bed asleep, and she's doing a trade-off between my need to sleep is greater than or less than my need to pee.
That happens to me 3 times a night.
Yeah, does about that time for me too.
You know, not very often can you hold it in that long. All right, you're going to have to enlarge this. Is it washed out? Maybe not.
Is it washed out?
No, it's okay.
It's
Okay.
okay. They're standing next to a brontosaurus in a tree forest, and the guy's about to take a picture. Or is
Yeah.
that a large dinosaur?
The Loch Ness Monster, Bigfoot, and Jackie Onassis are standing next to each other, and his camera jammed.
Okay, got it. Bigfoot. All right. Lead us through this one. 4 little squares here in the cartoon. Fido, stay.
The boy is saying to his dog, he says, Fido, stay. Stay in this exact spot in space. And the dog just starts drifting away because the Earth is moving.
Planet leaves the poor thing. That's why we can't go back in time. There won't be time travel, or we'll end up in a black spot in space.
Yeah, I
saw the plan ahead.
I saw another cartoon, but I didn't include it. It shows a boy or a man talking to a genie. He's just rubbed the lamp. And he said, I want to go back and visit the exact spot where I was born. And the genie says, I wouldn't do that if I were you. And he goes, that's my wish. And the next one, this guy's floating free in space.
You just said,
I was reading something about time travel and why you can't do it, because especially if you want to come back, where you left won't be there anymore because it's in orbit.
Yeah,
that's what we've been talking about. Yeah, that's the point.
Yeah.
Okay, there's a fish in stress or what? What's going on? 2 parts to this, Mr. President.
this is a dolphin, I assume, or an orca. It's funny how watching something so vast becomes one of the little things that matter.
That's deep.
Yeah, it's
Not
just
bad, okay.
the feeling you get when you imagine what the stars are like.
Is it a mammal or is it a fish?
It's got gills, so it's a shark.
Oh, that's
Oh.
right. Yes, good point.
Okay, got it.
Okay, that was 6.
That's not bad. Gets us all in a great mood. Now we go to the serious stuff, the night sky from hell. Here we go. Stand by. Maybe we'll get one of those simple blue.
Okay, this is
screens.
a chart I call Venus Finder. And here we are with Venus. This is 6 a.m. in the morning. The sky is getting light. The sun is about to come up. This is probably about an hour or less before the sun rises. And Venus is very close to the horizon. Anyone get up to see this?
No.
Not with my eastern horizon.
I'm referring to Tom. He usually.
Yeah.
It was pretty overcast last
Oh, you're
night.
muted, Tom. You're muted.
Okay.
There's activity here.
Okay.
Uh-oh.
Oh, okay.
This is the Jupiter Finder. This is where the planets are. This is part of our weekly roundup of the planets. Now, this is about 11 p.m. at night, and I did it so I could get the horizon in. This is the east, and this is Jupiter rising. So it's going to be up.
Jupiter is really bright.
Yes,
Wait till you can see it.
and this is in the constellation of Gemini. And we can see our winter constellation of Orion up here, which we'll get to later in the talk if we have time. There is a lot of stuff up here.
You know, I've been trying to see the Milky Way, but I can't see it, and I have to get away from the lights of Goleta.
Yeah.
Yeah, well, between the moisture in the atmosphere and the lights, you know, it gets washed out.
Well, we're in almost the same part of Goleta, and I'm just, you know, you could cut the fog out here and use it for paving stones. So thick.
Well,
This
I
is-
woke up early this morning. I think I woke up before 8 o'clock, and I look out. My deck is completely wet with puddles.
Yeah,
And
ditto.
I said to my wife, "Look, it rained last night," and she says, "No, that's just the fog."
Do.
Yep.
Anyway, this is a picture of Jupiter with the-
really washed out.
Oh, okie doke.
Missed Saturday night, Mr. President. We had a beautiful sky until about 8:30.
But that's before astronomical twilight, right?
No, it was quite dark.
Oh,
That's-
that's
that's
right.
early
Because we
now.
lost an hour. Yeah, we lost an hour. Or
Okay,
gained an hour, I guess.
This is a picture of Jupiter, as you might see it in a small scope. We did this a couple of weeks ago. It was a simulation of what it would look like in a small, like a 6-inch or a 4-inch telescope, an amateur telescope. If you were looking visually, you can, with the same telescope, you can take much sharper pictures by taking a video of it and then processing the video by a large scale stacking. But it's a good visual for doing in the old fashioned.
May I ask a question about that? Please.
What?
If you left the camera lens open, as they do for long periods of time, would that clear up and we'd see the strata better and everything?
No,
No.
go ahead.
Somebody answer that? I don't know.
Yeah,
Oh, no, it won't, because of atmospheric turbulence. And the bigger the scope you have, the worse that becomes.
Yeah,
Oh,
it would
is
go
that
the
right?
other way. It would get blurrier.
You
Yeah,
also
if you
have
take
the
video,
case.
and then there's a program called PIP, which will disassemble the video frames into individual frames. And then you go through and select the ones that are, if you watch it, the turbulence every so often becomes nil, and you can see it clearly. Well, you pick out those, and those are the ones you stack. So you might take 1,000 pictures and stack 50.
There's a limit to what you can do, though, because Jupiter rotates so rapidly,
That's right.
the features
Yeah,
move.
yeah.
10 hours.
Yeah,
So it'd be the great red. It'd be the great red hyphen.
Yeah.
This one,
But if you take
picture right
1,000
there.
video shots at 60 frames per second, you're only talking, I think, 16 seconds of exposure time.
This feature here would be over there in 2 hours. So it moves appreciably in a few minutes. So you take about 10,000 frames in a video or less than that, and you do what's called lucky frame averaging. So which means you go through and you look for when the atmosphere just accidentally lets you have a real clear picture. And you pick out those accidental frames or lucky frames and you stack those up, and you can get incredibly clear pictures.
And you don't have to go through them one by one yourself. The software
No.
can judge the sharpness.
Yes, good point. Okay, now for Saturn. Oops, where we are. Let's see, this is also about 11 p.m., but this is in the west. And Saturn's in there somewhere. Neptune is up here.
Saturn just below it.
Saturn is just below it. So you can turn from east to west, and you can see Saturn as it's going down. It will be higher earlier in the evening. And whoops. This is a similar picture of Saturn. Right now, its rings are very, very narrow. And this is Saturn and its moons. And it's simulated again in a small amateur telescope. I loaned my son-in-law a 80 millimeter, f7. And if you put in a 6 millimeter eyepiece or so, this is what it would look like if you're lucky and the air was fairly steady. Actually, it would probably look better because your eye will take a quicker picture. The exposure time for your eye is 0.04 seconds. So that's the shutter time that you have.
40 milliseconds, huh?
Yeah.
What
On
is-
average, it's, people are a little different. And when they get older, it's different. But so
do you know what the schedule is for it going side on and disappearing? The rings?
It already went through that.
we're
It's
just
already done
about
that.
we're just about to do that again.
No, it happened in March, and
No,
it's
we're just about to discuss that again.
yeah.
So this is a picture taken by, oops. This is a picture taken by Christopher Goh of Saturn when it was at very narrow. And I believe this was taken years ago, but this is what it would have looked like, roughly this, on March 25th of this year.
I think it was just in October he took that.
Of this
October 31st. So Halloween.
Is that what the caption says?
Yep.
Yeah,
Yeah, well, the caption's right.
Huh. October would have been 4 or 5 months after it disappeared. It was
Right, that's
several
October
years ago.
31st, just a week ago. So, and he used it with a 14-inch telescope.
And Andy in his scope was seeing the shadow of the ring on the planet on Saturday night. It was really steady seeing.
Yeah.
He also got some of the bands.
Yeah.
So the rings are still pretty narrow. I get these, I go through a lot of things on the internet looking for public domain and things I subscribe to. Sky and Telescope, Astronomy Magazine, space.com, which just popped up with another pop-up, and for me. And it had a puzzling thing on Saturn on the Sky and Telescope site. It said that we had the ring crossing on March 25th and also again on November 15. And I went back and checked that again yesterday, and I'm puzzled by that.
Yeah.
I think what they did was they took a paragraph from an earlier version of things, maybe years ago, and they put it in intending to edit it, and they just forgot to do that.
Yeah.
So it was very confusing. But I noticed that they do that at these magazines to save time. So anyway, going along. So it's not probably going to be, if this is what it looks like a few weeks ago, which is very nearly edge on, and you can see the shadow of the ring up here on the ball of the planet.
Oh, yeah, yeah.
Now we're moving on. This is Doug right there. And it's nicely placed between the Pleiades and the Hyades. And this is in the evening sky, the late evening sky, about 11 o'clock. And this is looking more toward, there's no horizon in this. This is up at a high altitude. Yeah. And a fellow has taken, an amateur has, this is Corey Marsh from Lanesburg. I think that's Minnesota or Michigan, Missouri.
The guy's name is LaDuca. That Corey Marsh is the location where he shot it. Yeah.
Okay. So this is Uranus and its moon, and he's listed them here as Oberon, Titania, Umbriel, and Ariel, and which is too bad because an easy mnemonic to remember the brightest 4 moons of Uranus is in the other order, AUTO, the word auto, AUTO. And that gives you a mnemonic for that. This is, of course, the planet. And this is Ariel there. Ariel's missing here. There it is. And there it is. So these are on October 29, 28, 27, 26. So on successive nights, you can see quite a bit of motion for some of these satellites of Uranus. So it's a nice set of photos if you want to take a picture of the planet, which is around 7 or 8 magnitude. You will not see it naked eye. You might see it with binoculars or a telescope if you know where to look.
And the moons would be tough unless you're either a very large scope or photographic.
Yes, exactly. Now he did the same thing. Oh, that's right. These are the same moons. Ariel, Umbriel. Here they're in the right order for the mnemonic. Ariel, Umbriel, Titania, and Oberon. They also added in there Miranda. And these things all have, they're all icy moons to some degree, and possibly with liquid water underneath. So, and you will not see these with your scope visually unless you're using the 100-inch or somewhere up above that or below that. Have you ever seen any of these in your scopes?
In Joe's scope,
Okay.
in the 18-inch Dob.
When you have an icy moon, is the ice mostly on the outside, or are they all solid ice?
The shell.
Yeah. See
The
this?
shell.
See, this has the, where's my cursor? This one has the fault pattern on the surface of ice that has been moved and flowed over and refrozen. So this would be the ice is on the surface. And this would be, so this coloration in this is, these are sort of photographs, but the colors are artificial. So this is an ice one. This is an ice one. These here are.
You can see the middle ones have a differentiated core.
Yeah.
What it's trying to show.
Okay.
Oh, two big layers.
By the way, I just read something this morning that on space.com that old data from our Venus landing attempts, that old data was processed, and they found a lot more iron and water in Venus atmosphere than was previously believed.
Water. Wow.
Yeah. So you'll probably see something about that, proof of alien landings or something.
You know, it's really funny with 3i. Avi Loeb has now invited Kim Kardashian to join his research team.
Okay, good luck.
I think that's a joke.
Has to be. But if we have a moon that has an ocean that's liquid, that means there's some heat going on. Chances are that moon's close to the large gas giant planet, and that's the reason it's liquid.
It can be that, or it can be radioactive elements in the core.
Because Io, I'm sure, is not an icy moon, is it?
That's correct.
But as hot as Venus is, it's got some water on it.
Steam.
Yeah, lots of steam.
Wow.
As a matter of fact, I read some article that was speculating that if you made a blimp or a hot air balloon or something, not a hot air balloon, but something that would float in the atmosphere of Venus, you could actually have temperate climate and oxygen and not the high heat or high pressure down on the surface. Of course, if your balloon sprung a leak, you'd be in deep yogurt, but that's the way it is.
Only for a short period of time.
Yeah, that's right. So this is a similar picture done by the same guy, R. Leduca, of Neptune and its major moon of Triton. They're there, and there, going around. Let's see, this goes around there. Okay, so this is elapsed time. Nice set of images. I like to show amateur work whenever we can find it. Now this is
cantaloupe.
What's that?
The cantaloupe.
Yeah. This is a picture of Neptune and Triton. Triton, we went by the moon, and it has these patterns here that look like stress ridges and cracks from where plate tectonics went on the icy outer layer and then refroze over again. So that one, this one, yeah, this is Triton, which we showed earlier, has oh, that was on Uranus. So this is on Neptune, and it's very interesting.
Triton also has these nitrogen volcanoes that leave the dark streaks.
Wow. What was Triton? Shakespeare or Greece?
Greece.
Grecian, huh? Okay.
Is that on the upper left there, Chuck?
No, more down in the center right or bottom right. Not, you know, about a third or a quarter up. You see
no, actually,
black.
I got the answer from.
So it's it just barfs the element nitrogen.
Yeah.
Yeah, I can have the elevator.
It turns black.
Yeah.
that's something that's,
Nitrogen compounds.
Is that also on Pluto?
Not that I've heard.
I thought it was nitrogen that gave us that big white heart. Or is that
Nitrogen ice, yes.
That's ice, okay.
But-
All right, you're gonna have to mute yourself there, Bruce.
Oh, you did.
No, I did. Okay.
Well, can I add one thing? You said
Yes.
you just heard this thing about what was it you just mentioned? Oh, floating in the atmosphere, the upper atmosphere of Venus. I happened to see that same thing, and I was wondering if it was misinformation because I never know. I cruise YouTube a lot. I also heard that within 10 million years, the rings around Saturn would be gone, sucked up by the planet. Stuff is falling into the planet. Have you heard of that? Have you heard
Yes.
that?
The rings are temporary, but I haven't heard a time scale associated with it.
10 million.
I've heard 3 billion.
Yeah.
Well, 3 billion.
Is it the solar winds that get rid of them?
No.
No, it's just they collide with each other and they lose some momentum and they end up falling
Yeah.
down.
Oh, okay.
But now, in an atmosphere of a planet like Jupiter or Saturn, they wouldn't have a fiery meteoric look to them, would they? There's no oxygen there, is there?
Well, you don't need oxygen for that.
Yeah.
Oh, you don't?
No, it's not fire, it's fluorescence.
So just running and heating up would.
Yeah. When a blacksmith heats up a horseshoe in his fire pit and takes it out and it's glowing white hot, it's not well, actually it probably is oxidizing, but it's not from the flame, it's from the heat. That's Planck's radiation law.
Got it, yeah. The whole thing about infrared comes from that.
Yes, well, all radiation comes from that law. So anyway, this is what it would look like if you were in a passenger spaceship going right by Triton and heading for Neptune.
But that's an icy moon there.
It's an icy moon.
Wow.
Now, it turns out that yesterday, or Saturday, I forget which day it was. No, it was scheduled for us yesterday, and I believe it went off. The New Glenn rocket, not an Elon Musk rocket, but Blue Origin. Blue Origin. This is an artist concept of one going up, but this is probably what it looked like if you were riding in a small plane and it went by you. So it launched the Escapade mission, which is a pair of satellites going to Mars. Now, this is an artist rendition of those two nearing Mars. They're going to fly around Mars in a coordinated pattern. What they're looking for is these two things are exploring in 3 dimensions the residual magnetic field in Mars. Previous spacecraft have either defined or suggested that Mars has trapped magnetic field in its minerals trapped from when it once had a dynamo effect and had a globe-wide magnetic field. And they're trying to estimate the strength of these things and if there's any use for them scientifically or engineering-wise for when they land in certain areas. So this is going to, it's the previous things, including Mars Global Surveyor, MAVEN, and the Emirates Mars mission HOPE, have shown that Mars lacks a global magnetic field, but retains patchy magnetic bubbles locked into its crust. So this will reach Mars. The Escapade will reach. What does Escapade mean here? It's Escape and Plasma Acceleration and Dynamic Explorers.
Big, long acronym.
Yeah, but I can as having participated in marketing, because when I was employed at SBRC, I had to write a lot of white papers and proposals. And if you have a catchy name for your project or your spacecraft or whatever, it will stick in the customer's mind more. And I didn't believe that at first. but several of my fellow scientists showed me that. And we came up with all sorts of acronyms for things, and they really worked in getting the customer's attention. So one of the ones that we sold to the Naval Research Laboratory was the FIRST detector, FIRST. It was a superconducting detector, and I don't remember what FIRST meant. So anyway, that sums up my view of marketing.
My favorite was Messenger, the Mercury mission.
Yeah.
It was like Mercury, environment, space, geochemistry, and ranging.
And we've seen examples of this sort of thing with some of the talks that we've got, like the Sphere X one last Friday, which was an excellent talk.
The EX stands for a whole word that starts with X. EX.
Explorer, EX.
Explorer, is that what it was? We've had the DART and the Psyche.
Yeah. Well, Psyche's named after the asteroid, so that's not an acronym.
Well, that's not an acronym. Well, why couldn't they put these two probes just on Phobos and Deimos, the two little dinky moons, or would they stay on them? There's not enough gravity, is there?
Oh, to sit on them? No, they wanna fly around them in formation, and the moons do not have that formation.
Is that right?
So this is going to go ahead.
I was just wondering if they're as far out from the planet Mars as our moon is from us.
I don't know how far up they're going to be.
They're going to be close, though.
Yeah, flying in formation, coming within 100 miles or 160 kilometers above the surface. They will do 6 months of joint observations flying in formation, and then they will separate into different orbits for another 5 months to build a 3D map of energy and matter flow between Mars and the solar wind, the process that controls atmosphere loss.
You know, if you could find a patch of strong magnetic field on Mars, it might provide you a little dome-shaped structure, you know, a dome-shaped thing that would help protect you from the solar radiation. It might be a good place to have a base.
Yeah, that's what I was referring to with engineering applications.
Yeah.
Aren't there orbiting probes already around Mars?
Yeah.
Oh,
We have we almost have an infrastructure around Mars. Things are on the backside of Mars. There are several satellites that are used internationally to send their information up to the orbit and then beamed back to Earth. We do cooperate. And by the way, China's in trouble with their space station. They sent, it contains 3 people at a time. They sent another 3 up there, and the 3 that were already there were going to come back. And then, so they had 2 escape capsules up there, and one of them got hit by space debris, and it's damaged, and they're not sure yet, but it looks like it's not usable.
Yeah.
So they're going to have to
keep all 6 guys there.
Yeah, they're going to, like we did last December and January.
Right, we kept 2 of them up there for an extra 6 months.
So I don't know if they're going to cooperate with them and use a SpaceX escape module. I hope they're compatible, or China's prepared to do it. I think the article said that China has another standby system ready to go.
Yeah, they'll have to jettison the damaged one and then redock with an unmanned one.
Yeah.
Does China launch from the Gobi Desert?
I don't know exactly where they do it.
Xinjiang, I think.
But I'm glad to see that China is coming on strong with their own space program. I think it was a mistake for the US to exclude them from cooperative space programs with us. I think we could have got a lot more advanced, but I'm really pleased to see China come along.
I think that was an attempt to slow down their ICBM development. Yeah.
Did I miss who's behind this escapade we're looking at? Blue Origin is the launch.
Yeah.
It's called the New Glenn. Is it ESA? Is it Europe, or is it NASA?
No, it's private. It's Jeff Bezos from Amazon.
Oh, does he own Blue Horizon or Blue?
Yes.
Yeah.
Blue Origin.
I
thought that was Branson.
No, that was Virgin.
Oh, Virgin. That's right. That was his.
By the way, the 2 satellites are named Blue and Gold.
Yeah.
And it was launched from Texas, wasn't it?
But UCLA is not involved, nor the Boy Scouts. of the University of Minnesota.
It
Wow.
could be a Navy thing, because the submarine, with nuclear submarines, they have two crews that they alternate
Yeah.
and one's the blue crew and one's the gold crew.
Well, the article I captured said it's from NASA. So
Yeah.
the actual probes were built by NASA.
Far out. There it is.
Now, this is
3i.
Yeah,
The
no.
Atlas.
Interstellar Comet 3i Atlas has not changed color, and it is not changing color. So that's all hype. It's not an alien spacecraft. And no matter what Kim Kardashian says, it's just a classic comet. It's acting just like every other comet does, except it spent a lot of time at near 4 degrees Kelvin or less in interstellar space. And now it's boiling in the light of our sun. It's now boiling off a lot of stuff. And that's what you're seeing here. It does have an unusual composition for compared to our solar system. And that's proof that it came from another solar system. And as we discussed previously, it is believed to have come from the thick disk of our galaxy, where we're in the thin disk. So it was a little closer to center, but not in the central bulge.
Well, can I ask a question about this and comets in general? We've covered this before, but I got to thinking, when it's way out far from the sun, everything is ice. It's frozen. When it gets close, it goes through a liquid.
No,
Does the ice become liquid and then gas?
no, straight to gas.
Straight to gas, no liquid at all. It doesn't
No.
ever.
And if it gets closer to the sun, the rock it's made of goes straight to gas too.
And I always forget the name of that. It's what it's called.
Sublimation.
Sublimation.
Sublimation?
Mm-hmm.
Yeah, I always forget that name.
But when the water is sitting out there around the comet as gas, is it little ice droplets or is it little gas molecules for that matter?
There's little ice cubes.
So it goes to gas and then back into.
One time I made a professional visit to Sandia National Laboratories in New Mexico, and it's very arid in Mexico. It's low humidity and high altitude.
Right.
I went in the morning, they had snow overnight, and I saw the snow on the ground. And when I came out in the afternoon, late afternoon again, there was no snow on the ground, and the ground was not wet. So the ice did not melt to water. It sublimed directly into the atmosphere.
As gas.
Yeah, because the air is so low humidity, it could hold a lot more water than it was. So it took the shortcut. So this picture at 3i Atlas is from the Gemini South Telescope.
What is the flare up at the very top there? The rainbow.
That's probably an asteroid or a satellite, something that didn't track with the stars and didn't track with the comet.
Exactly. This is taken from different pictures, taken through a different filter, a red, green, and a blue filter. And then it was superimposed, and things that didn't move appreciably will form a natural color to the human eye. But things that did move will form a colored streak.
Huh, nice.
Yeah. Okay, one of my favorite constellations, probably the first one I ever remember, and a bright winter constellation. We have a lot of bright stars in the winter if the air is clear. And this is Orion. By the way, not last Sunday, but the Sunday before, when I was running the 6-inch Lunt solar telescope at the observatory, the museum, a little boy came up and he said, "Guess what my name is?"
Orion.
I took a stab and I said, "Orion." And he says, "That's right."
Oh, wow.
You're a very lucky boy to have that name.
Well, can I tell my story about Saturday night real quick?
Go ahead.
Young couple, a guy in his 30s holding his child, coming out. I'm there in the dark greeting people, and I said, "What'd you guys see?" He says, "Well, we saw Saturn, but the one I didn't want to see was Uranus." And I laughed and I said, well, we call it Doug. And he looked at me like I was from Mars. He says, that's my name.
Whoops.
Yeah, well, he was happy about that. That's we refer to him every time.
Now, probably the most famous thing is about this is that right here, oh, it's going to make this bigger. Right here, this central star in the belt, or this is the belt, which when it was first delivered, I'm told Orion was very unhappy with it because he only gave it 3 stars. So here's the sword hanging down. The central part of the sword, the central star is not a star. It's the Great Nebula in Orion. And you can see that it's different from its neighboring stars with naked eye. So this is probably the brightest galaxy, not galaxy, nebula in the sky, because it is naked eye visible. And this is a picture of that in black and white. And it shows in there, the reason I picked this picture is because it's not overexposed in the center, and you can see.
It is in your display.
It is? No.
Yeah.
All right. Okay.
There you go.
Not overexposed in the middle. So you can see these 4 little stars making a trapezoid shape. And this is called the trapezium. And this is a blow up of it with its major stars. It's 4 stars. You cannot see these with your naked eye. And you can't see it with that label over it. But up in the upper left, you can see the slightly magnified view of it. And it's a test of how many you can see. And this is a schematic of that star cluster. And these are the ones. So I think I have seen 5, but you can see up to 9 stars in the cluster. Jim, how many have you seen?
Well, I've got a great story on that. Andy Allen had a scope one time that had a really really nice mirror in it, and had a good focuser. I think it was an 8-inch, and I had my 10-inch out, and other people had 9 1/4, and we were looking for the E and F stars. And Andy was over there just going, "No, they're right here." And
Yeah.
we went over to his scope, and there were you could see the E and F stars. But I have seen the E and F stars on really a good night.
Okay.
They're teeny, teeny, teeny.
And what was his diameter?
I think it was an 8-inch.
8-inch. Okay. Good job.
And he
Super
ended up-
good mirror.
It was a really good mirror. I think Jurgen, as usual, got that mirror, I think. But he had, what do they call those focusers
Helical.
the helical focuser, so he could really dial it in.
Yeah.
But we were all really bummed out because all of us were struggling, and he was just showing it off like it was nothing.
Did you say E and F? What does that mean?
They're the stars, like in brightness. A would be, I think A is like the brightest, although it doesn't show it there. The A, B, C, and D stars are the 4 stars in the ones that you can see easily in the trapezium.
Oh,
E and F up on the upper right and left there, they're very close to the A and C stars. And when you can split them off, it's a real good test of your optics and
of the atmospheric seeing.
And of the atmospheric seeing, Ronnie. So when you can get the E and F stars, and like Jerry said, you can get 5, but that 6th star, that's really tough. Except for Andy.
That's what these first 5 letters of the alphabet mean on this picture here. A is
Yeah.
the brightest.
Yeah. The E and F stars are the ones that are really hard.
It's not an order of brightness, but it's how they designate these stars within that Theta 1 Orionis.
They don't have names of their own.
Right.
Oh.
They're Theta 1 Orionis A, B, C, D, E, F, G, H, I.
But they're the main stars in a star cluster of what, a few dozen or hundreds or just
No,
a
just
handful?
in the trapezium here. So a few dozen.
Yeah,
Okay.
what Jerry was saying is maybe up to 8 that you can see, but to me, really 6 is what you want to shoot for
Right.
to test your optics, and that's like you need a really good steady night, and your optics have to be really good.
Now up here, up here, you'll notice these two stars. And the guy that processed this or made this schematic has shown how the separation of the two center to center, and this is 1.6 seconds of an arc. Now, when I take a photograph, the sharpest that I can get with a photograph with my scopes here at sea level is about 3 arc seconds. So I would
Ooh.
not be able to resolve this. This would look like one football-shaped star to me in
I see.
my pictures.
And they're hinting at that by both of these being H.
Yeah. Yes.
Yeah, the whole
Anyway, that 3 arc seconds is solely due to atmospheric turbulence here. And the best I can get it is about three arc second stars.
There's some nights, Ronnie, that you could just put A there. It's just blurry.
Well, I missed the name of this star cluster. What is it called?
The trapezium.
Oh,
Right down there in the lower right bottom.
Isn't there an orbiting dwarf galaxy to our galaxy called something like that? Or am I thinking of Triangulum?
Magellanic clouds, 2 of them.
Yeah, you might be thinking of Triangulum.
That's
Yeah.
what I'm thinking of.
Yeah.
Trapezium.
Yeah, but that's not orbiting our galaxy. That's up there with Andromeda and may participate in a 3-way collision. Nobody knows yet.
Trapezium.
Now another star formation is in the Hercules, where we're looking up at the M13, and that's also, I think, a trapezoid.
Yeah, the
It's more
keystone.
regular shaped, but it's they
Oh yeah, the Lyra. No, the Hercules, yeah.
Yeah, the
Hercules, yeah.
keystone. Yeah.
And they'd call that the keystone because it looks like the archway it looks like the keystone in an archway.
Hmm.
Oh, got some movement here.
Now
Cool.
this is a long exposure or a large number of short exposures stacked, which is more likely. Otherwise, if it was a long exposure, you'd see all sorts of jet planes and satellites and all sorts of crap going on.
Yeah.
So, but you can see a lot of the fainter structure in the constellation of Orion. This is Betelgeuse up here, or as
Yeah.
kids know it, Betelgeuse. And this is the belt down here. And there is the Horsehead
Flame?
Nebula and the Flame Nebula. And this is the Great Nebula in Orion. This is the 3rd star in the belt. Was this
In
one?
the sword.
Rigel?
Sword, yes, yeah. And this is the Witch's Head.
Witch Head Nebula.
Witch Head Nebula, yeah. And this is called the
Barnard's Loop.
yep.
Oh, that's
Now this is relatively faint. I've never seen this visually. I've only photographed it.
yeah, I haven't either. I always wondered what Barnard's Loop was. There it is.
Yeah.
But all those stars and the loop are in the same area of the sky. We're not looking at one way beyond that just
No.
happens to become part of it. Like the
That's
three,
right.
the 3 in the belt, are they close to each other?
They're at roughly the same distance from us.
Uh-huh.
So
Okay,
they're relatively close to each other.
I
This
can
is
never
the same,
remember the names.
this is the same region as the naked eye would see it.
Yep.
right.
Barnard's
Betelgeuse
Loop,
is way in the foreground, and so is Rigel.
yeah. It's Rigel. Which one's Rigel? This one?
That
Yeah.
one. That one.
Huh.
This is much more dramatic.
Yeah.
And I
But
think
the same
Bellatrix
way.
is the one off to the right there from.
Yeah. And the other one's Saif.
Yeah.
Oh, really? Okay.
But the colored loops is all gas clouds, gas and dust, right?
Yes,
Yep.
yeah. Different excitation systems got things going on here.
And what are the belt stars? Chuck, the Analak,
Alnilam, Alnitak, and Mintaka.
Mintaka.
Well,
Neat names.
They all have to do with groin.
Or belt, yeah, or waist.
Yeah, I can never remember those. The neat names, really neat names. Boy, that's a neat image, Jerry.
Yeah, I always like this one. I've happened on it a number of times and I hunted it down for this.
What kind of filter would you use for the witch head?
Oh, with this white thing?
Yeah,
This looks like a well-processed RGB.
okay.
And so that's, I would get all this features in these colors if I just use those three fill filters, yeah.
The witch head is a nebula like the Merope Nebula in the Pleiades. So it's dust. So it's not, it's just the blue reflection nebula. It's not emitting. So
It's not going to be easily seen visually, right?
yeah.
So there's the probable source of the light for that.
Okay.
Now,
Did you call up the witch head during Halloween?
Yes.
We did, okay.
Now this is M78, which is in that photograph of Orion, but it's not easily spotted. So it's up here somewhere. Let's see.
It's down by, well, I think it's farther down. It's just above the Orion Nebula.
Oh, this part?
Yeah.
M78?
I think.
You might be right, but I thought I saw it well, I'm not going to find that.
Now, Chuck, one more question for you on this. And would a sea star be able to see that witch's head? Witch head? Is it too big for it?
Possibly.
It's big enough for a sea star to get it. Yes.
Yeah.
Maybe
Be worth a try.
Yeah.
I got to talk to David because I think he has the 3 as well.
The 30, yeah.
The 30. I think that might be a 30 object.
Well, if you don't mind the host letting his ignorance hang out again, are the pillars of creation or the horse head anywhere around here?
Yeah, the horse head.
Horse head is.
It's not in this picture, though, is it somewhere?
It was in the earlier pictures.
Yeah.
I mean, Jerry pointed it out.
It's got to take a strong scope, I would think, to zero in on that little horse head thing.
It photographs well with even a small scope, but visually it's tough.
Tessa had an amazing image of that in her sea star, Ronnie, up at Westmont. There it is.
Oh, okay. All right. That black horse head shape, now, does that represent a hole in the pink cloud or black dust blocking everything?
Yep.
It's blocking. It's in front.
Yep.
Okay.
Very thick.
So, in other words, that's part of a nebula?
Yes.
Yeah. It's just not illuminated.
And
Or
visually,
33, I think, right, Tom?
Yeah, B33.
and visually, that horse head, I mean, in looking through in a dark sky with Joe's 18-inch, you have to imagine it. It's that hard to see.
It looks like a thumbprint. You don't really see the horse bit. You see his neck there.
I could hardly see anything. It was just
The listing I have is that it's IC434.
But if the horse head is a nebula and the pink sky behind it is a nebula, is one nebula blocking another nebula? Is that what?
Yes.
It's a nebular complex.
Nebula.
And different
Wow.
parts of it are illuminated in different ways by different stars.
And all those other blotches that are different colors around, those are different nebulae.
Yes.
Yes. Well,
Wow.
they're different parts of the same nebular complex.
Yeah.
Oh. Okay. Does the pink mean it's oxygen?
No, that's hydrogen.
Hydrogen is pink.
Hydrogen alpha.
What color does oxygen?
Green.
Green.
Comes out green. Well, that makes sense. It's my favorite color, green.
Yeah.
There
It's
you go.
twice ionized, Ron.
Oh, is it really? Oh,
Yeah, O3.
I love a green valley and I love breathing.
I always wondered why they say twice ionized, so it's O3.
That's one of those astronomy weird things or chemistry weird things.
It's chemists.
Yeah.
Well, our January speaker is going to be a UCSB professor talking about ionizing early galaxies. I had no idea. Now I'm hearing that over and over again. So I'm going to learn a lot about ionizing, whatever that means. Okay.
So this is a region of NGC 1999 right there. And it's this whitish, bluish gas cloud here. And it's got a little hole in it. And this is, at first it was thought to be a dark nebula in front of this nebula. But the article I read said that now it's recognized as a hole in this gas cloud. So, pardon?
I'm just wondering if that hole is something that might be a stellar wind that's blown things away.
I have no idea. I'm skeptical.
That's what the little caption on the picture is hinting at.
Call it a mini void.
So anyway, there's a lot of structure in here. This is typical of the complex of Orion. There's a triangular or almost a right angle nebula there, little trailing dribble down there.
And all those HHs are Herbig-Haro objects, and those are young stars just starting to form.
Yeah.
One night, again, Joe Doyle had his 18 out, and he had the Horsehead Nebula filter in, which shows red. It's reddish. And he put it on got a real big picture of that nebulosity in the thick clouds in Orion. And you could see these spooky little red dots, the young stars poking through. I've never seen that since. It was a really kind of a neat view. C-Star couldn't do that, by the way.
This stuff? No, this is too fine a detail. Here's this very nice triangular feature here, a result of strong stellar winds compressing and blowing nebular material. And Chuck points out Herbig HH region up here that are going to become stars probably.
Wow.
A gas cloud, HH all over the place. Bow shocks. There's a lot of structure. There's a lot of things going on here. This is a stellar nursery.
Is the entire region, Jerry, is it kind of the result of an old supernova? And it's this.
I have no idea.
A lot of it's probably primordial, but there are definitely, heavier elements there. So it's multiple supernovas, if anything.
Because it's an awfully large area of gas. So,
oh yeah,
here it is again, right there. It's a huge area of gas.
Yeah, there's that whole. I mean, even some of those dark and brownish looking bits. That's all molecular complexes. So
yeah. It's unbelievable.
And a lot of these gas clouds are actually organic molecules.
Yeah.
What does that mean?
Amino acids.
What does that mean, Mr. President?
What's that?
What does organic mean?
Amino acids, things like
carbon bearing.
Yeah, hydrocarbons
and stuff.
Butter.
Tending
one meteor had a hydrocarbon in it that they called it a butter version of butter.
Some of that stuff points toward the possibility of life.
Chemists go nuts over a few molecules.
Yeah.
But you can pretty much say if it's pink, it's hydrogen. If it's green, it's oxygen out there.
Pretty much.
Yeah.
And if it's blue, it's dust.
Again, it depends on who processed it, how they processed it, and what filters they used.
Yeah.
Yeah, I asked the guys in the workshop one night, I said, now, are these colors real? And Jerry said, they're all made up.
But some of them try to approximate
real
vision.
Again, I've brought this up before, Chuck, but when you say dust, what are we talking about? Chunks of
little pieces of carbon and molecules of organics, like Jerry said. And silicates.
Okay, but not little pieces of actual dirt or rock or anything like that.
Yeah.
Oh, you can get that? Okay.
Yeah.
Oh, what's that?
And our final one for today is also in the Orion complex. And this is NGC 2174.
Huh.
Do you remember its
And
common name?
number.
The Monkey Head Nebula?
No.
Monkey head. I don't see it, not yet.
No, I don't either. You have to squint, and go back. So let's
It looks.
Yeah,
sort of
maybe
like a
that
walrus.
central part with the two eyes, but
Yeah, the two eyes there.
yeah.
Oh, I see, got it.
There it is. And the mouth is down at the lower left.
Yeah, I think so. These names are someone, maybe they had too much to drink for dinner. They're now out with a telescope and they're starting to see pink elephants in the sky. You don't know. Depending on who it is, the name sticks or it doesn't.
If you had a couple of tusks, you could have a walrus, maybe. Well, look, gentlemen, you dazzle me again. I'm going to think about this and probably dream about it. But thank you for regaling us with info. And I don't know what happened to Bruce, but I hope he's okay.
Yeah.
Welcome back to the screen, Tom. Got to
Yeah.
check the old bread in the oven, don't you? You
That's exactly what I was doing.
animal. Yeah, well, let's do it again. We will reassemble here on the screen for Zoom next Monday morning, everybody, for our 247th episode of the SBAU Astro Hour. Please tell your astro-loving friends. Check sbau.org and plan to join us for our club elections on the 5th. By golly, how do we say goodnight, Gracie, in our Chuck?
Asta Nebula.